A 5,000-year-old blue pigment is giving modern scientists clues towards the development of new nanomaterials with potential uses in state-of-the-art medical imaging devices, remote controls for televisions, security inks, and other technology, according to an article in the Journal of the American Chemical Society. This is ACS Breakthrough Science, Research in the News.
Let me start with what Egyptian blue is. It's an inorganic compound, calcium copper tetrasilicate, within a matrix of glass and other components. It was the first pigment to be made by people. It was already being done on large scale in the 3rd millennium BC in ancient Egypt and Mesopotamia. So this material represents an important milestone in both the history of civilization and the history of chemistry. Our research is driven by questions about the properties of materials. Egyptian blue is special because it emits radiation in the near-infrared region. This means that it emits radiation with a wavelength of about 900 nanometers. There are very few materials with this property. Most of them contain rare earth ions. In contrast, Egyptian blue is composed of calcium, copper, silicon, and oxygen. They're all very abundant elements. Our biggest surprise in this work was that Egyptian blue could be disassembled in hot water. That's it, just hot water. No fancy chemistry required. We also show that we can use inkjet printing to deposit and pattern these nanosheets on a surface. The next steps of this research are to look at other chemical compositions that are related to Egyptian blue, but slightly different. And in that way, we hope to tune the near-infrared emitting properties. We're also looking into some of these applications and developing solution processing routes, like inkjet printing, to be able to fabricate devices out of them. So for example, many telecommunication platforms are based on near-IR radiation. Security inks to prevent the forgery of currency or other documents, or possible applications in biomedical imaging. This is based on the fact that near-IR radiation penetrates through tissue much more easily than other kinds of radiation. It could make it a much more effective imaging technique. We're really delighted about all the attention this work has received. It means the ideas are reaching an audience that goes beyond the usual chemists and material scientists. Our nanosheets have been highlighted by Scientific American, by the Material Research Society, and by the radio news show of the AAAS. I love the thrill of first discovery. And that feeling is amplified 100 times on this project because we're working with a material that has been around for so long, for millennia.